Hello, welcome to Plutus Experience number 7. If it's your first time here, the link for the first video in this series is in the description. Please subscribe and tick the bell to receive notifications on new release. If you're following us so far, please leave a comment below so we can know each other. And also, please share with other devs if you find this useful so we can build a community around it. In this module, we're going to see row types, records, monad transformers, async computations, Aff, and we'll build a wallet web app using Halogen. You will need Nix Flakes, and PureScript. So it's important to really understand the content of the previous modules before starting this one. So row type and records. Let's remember kinds. Here's an example of a kind. Here we have the concrete type and the kind signature of a type. So the concrete type is called name in this case here, and it's just alias to the string type. And we call concrete type because it's just type. So we can use the kind notation like that to define the type, the kind, and the type to define our custom type, in this case name. Here we have another concrete type. So the concrete type here is dog, and you can see it has the kind signature type, only type, so it means this type is just a type. And we have the high-kinded type, and the high-kinded type has a different kind signature. As you can see here, maybe takes a polymorphic type here in place of this E, right? So how do I know this is high-kinded type? Because it takes a type and returns another type. So anything that depends on another type like that, we call a high-kinded type, okay? And the value here, so this kind signature is pretty similar to a function, right? It has this arrow thing here, and the meaning is the same. Here it's saying that in the first argument we receive a type of kind type, and this type should return a type of kind type. So we take a type of kind type and return another type, maybe, of the kind type. So when we see a type that depends on another type like that, we say this type is high-kinded type, okay? So in this case, maybe here depends on E, and E, because of this kind signature here, is a type of kind type, okay? So here we have a partial application of that maybe before. So we could say that maybe dog is a conjunction or a merge of maybe and dog, or we maybe even better, we can say that maybe dog is the application of maybe on the type dog. So we pass in the place of this E here the type of kind type, in this case dog. So that in that way we build a new type. So now we say that maybe dog is a concrete type because it does not depend on another type of any kind. In this case, we say this maybe dog is a concrete type. So you can see a pattern here, and the pattern is every time that you have a type that has only the kind type, we say this is a concrete type. And every time we have something dependent here, we say this is a high-kinded type. And here we have a function application with that maybe dog. So we have the maybe dog function, and the type signature of the maybe dog is using that maybe dog type. And we don't need to pass dog anymore because it's applied in this maybe, but this function returns a string. And here we have, if this value of maybe dog is from nothing constructor, we show the dog. Otherwise, we're gonna show the dog name. So we extract the baby value with using the just type constructor and the dog value using the dog type constructor. So the result of running this should be, in this case, in the first case, a no dog, and the second case, just dog max. So we have no dog here, and we have the dog max here. As expected, we are showing only the name of the dog in the function implementation, actually. So let's see what problem here. What problem row types and records try to solve? What if we need to have a way more dog attributes beyond name? We could use some types. That's one way to do that. Let me zoom here so I can follow. So here is a solution using some type. So we basically use normal types to do everything. So here we have the function main, and the function is showing the is logging in the console the return from show dog, which takes a dog and returns a string. And we pass a dog and we use this type here, dog. So the main function here is return the log, is logging the console, the return from show dog, which is a string. It takes a dog, and we build the dog using the dog type constructor for the data type dog. And the type constructor takes a name, an age, and an owner. And those are just alias to underline types. So in this case, name is a string, age is an int, and owner is a name. And name is also a string. So that way we have a dog being made with the dog type constructor max2 value and John string value. And because we are logging that in the console, we have max2 and John like that here. So the show dog is transforming that dog into a string by extracting using parent match using the dog type constructor and the name, age, and owner attribute, and show dog is appending using the append operator, everything with commas. So that's the result from that. So it's a bit clunky, but it works. Why I say it's a bit clunky, it's because we have like this huge type. Imagine that we have many attributes beyond just name and age and owner. Our type is gonna be huge. So that should be a better way of dealing with many attributes in this a type like that. So let's explore this row kind. As you can see, we have this row data type, and it has this polymorphic E. Okay, this E is of kind E, so it's a polymorphic kind in this case, right? Because we are passing E here in the kind level, in the kind signature. So it means that the row can be of a type, for example, or it can be of something else, like a custom kind, for example, right? And there's a native constructor in the language that allow us to build this row data type. Actually, we don't create that row in the language itself. This is I mean, we don't build that row. The data type is handled by the language itself. So the type constructor of this row native type on the language side is this parenthesis, and we have this construction here. This construction, we say this is a label on the left side, and on the right side it's a type. So in this case, we are building a row type, and the type constructor of that row is this parenthesis, and the type constructor has a label, which is label, in this case literal label, and on the right side we have the type. So whatever we pass in the row, it's gonna be it can be a type, or it can be something else. We're gonna place on the right side of the label, right? So here's an example. We have the type dog, and the type dog has the kind a row. So this is a kind, right? The row is a kind in the language space. And we apply the kind type to that E here. So we have a concrete type of dog being of the kind row type. This is different than just type, right? Normally when we create types, we had just type here, not row. So here we have row type. This is a different kind, okay? So the type dog now, so it uses the type constructor for row because we need to build type that accepts this row type kind. So we need to use this parenthesis here as a type constructor the same way, okay? And here we place the label. So in this case, the first label of the dog is going to be name, and the type of the name is going to be string. The second label is going to be age, and the type is going to be int. And the third label on that dog type is going to be owner, and it's going to be string. So some important comments here. Label E is the type constructor for row at the language level. So remember, we have the value level, we have the kind level, and we have the language level. So when we are talking in the language level, we are talking about stuff that is embedded in the compiler itself. Okay, it has a representation, so we can use that. It has like operators, it has custom types that we can use at the language at when we are building something with the language. But this is in the language level. Okay, so this kind of construction with this parenthesis represents the type constructor of the row custom kind. So wherever you use row type, we need to use a corresponding kind constructor, or say something like that. And the kind constructor of that kind is going to be the parenthesis. And it receives the list of the labels. It's not a list, but it's something that the compiler knows what is that. It's a compiler construction. Name, age, and owner are so-called indexed labels, okay? And because a row type, we can only have concrete types in labels. So this is an important thing, okay? We cannot have anything beyond this construction here. So whatever we pass here in this string should fulfill this E. And because of this E, it's just a single thing, we cannot have high-kinded types here. Okay, so that's the third explanation here. So you can see a row type like instructions on how to create a dog definition. Okay, it's important to note so far we are not dealing with any value level stuff. Okay, we are talking only about type level stuff. Great, but having a type that can't be used to build definitions is not so useful, right? How can I build a type and a value of dog type? So because we need to build at some point the value of that dog, right? Let's see. Records. So this is the data type for record, also embedded in the compiler. The kind of that data record is a row type. So it receives a row type, the kind, okay? And returns a type, okay? I guess it's missing some E here. It should be probably, it's incorrect here, but you get the idea. It must receive a row type to return a type, okay? The record itself. So record constructor, I see. Actually, this is not the data type. This record here is the constructor. It's the constructor type signature, okay? So the constructor for record data type receives a row type and returns a concrete type. We're gonna, if you're like following so far, we're probably being wondering, okay, here is where I placed that row type we created before. Yeah, you're right. That the place we fulfill with the row type we have created in the previous slide. So what is the record constructor is saying to us here? Given a defined row type, give me a corresponding concrete type. Okay, pretty simple. So here's the type dog, and we can see it has the kind type, so it's a concrete type, normal type. And the dog is receiving the return for calling record, that record type constructor, passing the row type we created before. Okay, so we pass this row type and we pass the labels inside of that row type. Okay, so we build that row type and we pass the row type to the record. We apply the row type to the record type constructor, and this is gonna return a concrete type for dog. That's it. That's how we create a record. Okay, so everything so far in the type level. Let's move on to see how we're gonna use that. So like your row type, record has also a syntax sugar constructor. So we can remove record and the parentheses altogether and replace by this syntax sugar. It's the same thing of the parentheses, but it is like a composition of both things. So in this case, we have this construction here we can use to replace both things. And we also need to pass the indexed labels in this case. We are passing them here. So this is the type dog, the same thing. You can use both syntax, there are no difference. Now let's see how we can use that in the value level. Here's a small implementation. You can see there is a main function, and we log in the console the return from show dog, which takes a dog and returns a string. The same thing we did before, right? And we can see the output here. So this log is showing Max, Stu, and John. And you can see we are building the dog from this type dog here using the same construction. So that's how we build value level stuff for record. We use the same construction. We use it in the type level. We use that in the value level. And here we pass the label index right here, the indexed label on the left side, and on the right side we pass the value that's gonna fulfill that indexed label. So in this case, name should receive string, age should receive int, and owner should receive string. So with that structure in place, the compiler will figure out, okay, this is the dog, okay, and show dog is expecting that dog. So how the show dog function works? We can use our normal reference to variables. We can define a variable here, the argument sign of the function, right? And refer that way we are doing here. So we are showing the dog internal value age using that dot operator. So with that in place, we just access the age of that dog. And we can also use pattern matching like we're doing here. So we can access the name, and in this case owner, but using this name instead. So we reference to this owner name, which corresponds to this owner. So with that, we're gonna have the value instead of that owner here. So the value is a string, okay, which is John in this case. That's it. That's is record. So let's see how kind of problem we can solve with that. So optional field problem 1. What if owner is optional? So imagine that we have this function main here, like before, show dog like before here, and we are passing this dog here. But I want my use case, my business scenario demands that I need to have optional owner. Or, I mean, owner should not be always there. It should be optional. How we can do that? Well, we could use a maybe John here and use a nothing when the value is not there. That is one way to solve that problem, but there's another way. And we can see that if you try to do that like we're doing here, just not pass owner, we are not allowed to do that because the type is expecting that owner here. This is in the type signature, so we need to fulfill that. You can see the type error here, type expression. lacks required label owner in the second case here in this lead age value. Okay, so the compiler checks if it has the required labels. In this case, it does not honor. It does not has honor, so he's gonna blame on you. You need to solve that somehow, okay? And there are tools to do that. But let's see. We have another problem that we normally have when dealing with records. What if it show owner needs handle only owner? So let's say this show owner here, we have this this is other function. It's another function. We had the show, we had the show dog before, and now we have the show owner, okay? And the show owner is gonna take only the owner of that value we need to pass to owner, okay? And it should show that. This is like a business requirement to do that, okay? And our main function now is it's building this dog, okay, with the name Max, age 2, and owner John. And it's trying to call show dog, passing this dog, okay, that has the name, age, and owner. And it's trying to show owner and passing that dog and expecting that you know how to handle that dog, and it should log that. So what we have in the type signature of the show owner here is just a type ownership, and it's also a record that takes a string. It's pretty, it feels feasible, right? It feels that you could do that somehow. But actually you can't do that. The compiler will throw this type of expression contains additional label age. While checking that type age int name string owner string is at least general as type owner string, while check that expression dog has type owner being string in the value declaration main. So what is happening here is that the compiler is trying to match this dog being passed in the show owner with ownership. And if you look here, you're gonna see this is another record. It's not the same record. So he's gonna say the record we are passing here has name and age. And I don't know. I refuse to handle that. I refuse to do that. And you can be wondering why PureScript does that. I mean, every language out where every language you see there does not do that. And the reason PureScript does that is because PureScript is a pure language. And by pure, it means that you can't have partial things in the function. Everything should be explicit. And the reason is to avoid errors and avoid bugs on your application. So the compiler tries to do everything possible to understand the types you're passing by, but the compiler will refuse to do anything that can add bugs on your application, that can add partial applications in the functions that produce side effects and things like that. So the reason is that, okay? So we need to build the type following the standard way of doing that. There's a way to do that, and I'm gonna show you. So open and closed rows. So this is a closed row. You can see the type dog here has kind row type, okay? And this is a closed row. We're not talking about the records now. We are talking only about the row, okay? So this is a row, and you can see the row has only name, age, and owner. So nothing new here. It's the same thing we did before. But we say this is a closed row because it does not allow us to remove things or add things in that row, okay? And here we have an open row, and we can see the type signature of dog is quite different now. The kind signature of this dog is a high-kinded kind. Okay, so the dog has a high-kinded The dog is a high-kinded type. It receives a type of the row type kind on this polymorphic E and builds a new row type where it uses this E with this operator right here. I guess the name of this operator is pipe, but I might be wrong. But the idea here is to allow to merge in this row type the labels of that row type. So when we do that, we have like a placeholder here, and this placeholder is gonna merge wherever we pass here. Is gonna merge this row type with this row type, these indexed labels here, and we're gonna have a new row type. Okay. So dog is a high-kinded type. It needs E, which must have kind row type to define its concrete row type. So here we have the ownership. It's a row type, and it has only the label owner being a string. Pretty similar to the record, remember? That has only owner. Here we have the dog, the same thing. It receives row type, and it has a polymorphic E here that needs to be fulfilled. And here we have the dog with owner being a concrete row type of the concrete row type kind. Okay, and the type dog with record applies to this dog here. This is a high-kinded type, so it applies in the place of this E the type ownership, which is actually a row type and not a type. So we pass the row type, this row type match this row type here, and we can merge this row type with this row type here. So this is gonna give us our dog with owner. So it's gonna be the merge of this row type, so far up to here, with this owner in place of this E here. And of course we can have as many labels you need to in the place of this E. Okay. So remember that our row type is the instruction on how to build a type using a type constructor record that takes a row type and returns a type. So with that in mind, let's see the open and close records. So this is our closed record, the same we did the past with the dog, okay? And the same thing as the row type, but this is in the type level. So this is a type of dog. And here we have the open record. And you can see that the open record takes also a row type, not a record. You see that difference? It's not a record, it should be also a row type. So if you're expecting, hey, if here we have a row type, in the record we should also have a record. Nope, that's not the case. We need to pass here a row type, and the compiler is gonna see, okay, this is a row type that I need to merge with the row type of this record here. So the compiler will do that. So this polymorphic E is the same thing we did that with that row type, and we're gonna merge the label on this row type being passed here with the labels here to build this record. Dog in this case is a high-kinded type because it needs to fulfill this E here. It needs E, which must have kind of row type to define its concrete type. So here's an example, type ownership being a row type like before. Here we have the type dog, which receives a row type to produce a new type. It has this polymorphic E. And here we have the dog with owner being the dog applied to row type ownership. So we have now the dog that we can use in the value level, the same way we did before. But in this case, an open record. Okay, so we can build records with owner, with anything else in the type level and use that in the value level. So dog with owner is the concrete type of a dog. Result of applying ownership to the dog high-candidate type, which apply the receive ownership to record row type to type as first argument. In other words, we use ownership row type to tell dog how to build a type using record type constructor, which is hidden right here. Okay. So this is the solution for our problem. Now we have a solution for that. Look here in the log, we have the show dog showing the dog 1 that has name and max age 2, owner John. Then we show the dog 2 that has only name Lily and age 3. Then we show owner of the dog 1. So we need to show only this owner here on this dog 1. And here we have the dog 1 being shown. And the function dog here, you can see it takes that name and that age and show that accordingly. So we have the name and age here in this show dog 1. Show dog 2, also name and age. So show dog 2, show Lil and 3. And finally show owner, only show the owner. So we have the log of show owner, which is just John. And here we have the comment show comment here, the show owner for dog 2. And if we comment here, we're gonna have a compiler throw saying that likes required label owner to show you that we cannot use show owner with something that does not have owner, right? It should throw. So in this case, if you try to use show owner with dog2, which has not owner, the compiler figure out that at the compiler time instead of the runtime, which is really useful and powerful. So let's see the implementation, right? So the ownership row type having only owner. The dog is the same we did before, but open dog now, polymorphed by this E, which is the row type, which is going to be this ownership. Here we have the dog with owner being a type, concrete type, and we apply that ownership to that dog. And the function signature is quite different now. You can see this is important here. We have the string being returned here, and also it takes a dog. But in this case, it's look that we are not using dog with owner, of course, because we are not expecting owner here. And we are using this polymorphic E here. So we accept anything in place of this E here, and we are not handling that. Okay, we're not handling that. We can use parent mating like we do here. And you can be on the, hey, what if I need owner here? What if I need owner right here? What the chain I need to do here in the type signature to have owner here? Well, you can just pass dog with owner, or you can pass a dog, and in place of this E, place ownership, so you can have access to that owner. Everything type safe, so you don't need to worry about all applications, functions working in an inspected way, because everything is already static in the type level. Of course, the same applies for show owner. You can see that we expect, in this case, a quite different thing here in this show owner. Of course, I could pass something with ownership, but that's not, I guess, possible. because the ownership is a row type, and here we need to pass a type and not a row type, okay? So in this case, we just build a record here type, and this record should have the indexed label owner, and we have a polymorphic E here, which stands for any record type. Okay, so with that in place, we can have access to owner in a safe way, and we can do that because of this polymorphic E right here. So we can show that, and everything works at the compile level and not at the runtime. I really recommend you to go deep on that record stuff because it's really it's not that complicated. I mean, the first time it feels like complicated, but it's not so complicated. You can have more info on the on more syntax stuff, syntax sugars on that page on the JAWS reference. Of course, you need to see how to mutate things, how to it's not mutate, but how to build new records with the old work. There's syntax sugar for that. I really recommend you to go there and see by yourself. Okay.